The video you're watching is about precision and how good we have it, and how little work it requires. Let's say we're going to do a number that's unimaginably large and on a practical level is practically infinite from our scale. We're going to use the solar system as a scale to work with for a math problem. We're going to use an interplanetary navigation calculation example. We're going to use the distance from the Earth, or just the center of the solar system if you want to be silly, out to the distance where Voyager 1 is. That's the most distant spacecraft. That's the most distant object we have ever been able to create an outcome for so far. And it's technically outside of our solar system because it's out in front of, or the edge of, the bow shock of the solar system as the solar system plows through time-space, being dragged around the outer edge of the Milky Way galaxy. So it's in interstellar space. We're doing interplanetary space math here, but let's go there. And let's decide to do something involving pi for this purpose. Let's say it's 20 billion miles out, either from the sun or from the Earth or whatever. It's actually shorter distance than that, but let's call it 20 billion miles for the hell of it. We'll use that as the radius, and we'll use that to do pi and figure out a big circle based on that number just for the sake of argument. And we end up with 125 billion circumference, 125 billion mile circumference, or the distance around a circle we've arbitrarily created. This will have an accuracy or defect criteria of being just under 1 inch of error in 125 billion miles. Now, if you're not aware of it, we go to 1,000. We need three zeros. Okay. That's one set of 3. The second set from 1,000 is 1,000,000. Then we go to the second set, 1,000,000,000. Okay, so we're doing a pretty big number. Now, if you take 125 billion miles and divide it by a certain number of decimal places to get it under 1 inch, how many digits is that? Okay, if we use pi to 15 decimal places and then do the math routine, we end up getting why NASA uses it. We get an accuracy that's plus or minus 1 inch in 125 billion miles for this big-ass number we just created just to see what would happen. On a mathematical level, you can do that with scientific or preferred engineering notation. By the way, Google refuses to use engineering notation. That pisses me off. Seriously. But anyway, that is a memorizable value of pi. I prefer the one that has 16 digits beyond a certain point because it's easier to memorize in pairs. 3 point, and then we do the numbers as 14, 15, 92, 65, 35, 89, 79, and then 3, 2. But if we just chop off the 2, we get the 15-digit number because it's correct, and we want to make it to where the last number we chop off is a low number below the number 5. That's all that's required. That way, the worst case scenario will be plus or minus an inch, but it'll be definitely below an inch just by doing that one bit of real simple trickery. You can pick an arbitrary point along pi where you see something close to a 0, for instance. Another one occurs, I'm looking at a really long one over here, that's what she said, that's out to 37 digits past. Okay, so at 37 digits, we can do 36 digits, and it ends in the number 1. But if you rounded it up from the other number, which is an 8, you end up with 2. We end up with numbers that are good enough at this scale that we're only off by an inch. And again, it's in motion. As soon as you've done the calculation, it's wrong by more than an inch, easily, because it's traveling thousands of miles an hour. But anyway, that version of pi that I read back as pairs, I will end it with the number 3, 2, and that's one I memorized for years to type in by hand to write pi into programs I used. Pi to 16 digits, as has been used since it was figured out and has been accurate since the year 1424. It's been around a while. It has a 1 millimeter error in 125 billion miles. Or if you calculate the Earth's diameter and circumference from it, you end up with something on the order of molecule level accuracy at the equator. as an error. And it can be memorized, and you can also calculate it from a couple of arbitrarily large numbers that you divide, and you get a very similar number, or just memorize it. This is the reason it's just recorded in your computer, and the computer doesn't do an equation. It just uses this as a pseudo-constant. And again, you want to look for a number like what? Well, the reason we use 3.14 is the next number is 1. And then when we go further down the numbers, we end up with 2s and 3s, but we want to see another 1, so we have the least amount of bullshit going on. And that's where you get 30-plus digit numbers being used for higher precision if you need to. Reality doesn't require that, because any orbit or path or anything of any practical value you're going to use that would involve a circle is going to be an estimate from the get-go. And this becomes escalating decimalism. And on that one that's X number of digits long, the equation you have to type out, by definition, has to be smaller, or it's a waste of space. It's actually just a little smaller than the number you end up with, but it's not really a big deal. And again, you end up knocking off the last digit if possible, and that one ends in the number 418, so you knock off the 8, the 1 is the value. Or you can just say it's 2 and be wrong up. Now, why am I making this video? We've known about this shit since the 1400s. Since the 1700s, we've had the 37-digit ones. We as a species have known how to do calculations that are down to incredibly tiny details. For the radius of the universe and creating a circumference, even though it doesn't really have a border to it, we can get down to, if we do the number to 38 decimal places, we end up getting it down to being plus or minus accuracy for how big around it is, which we can't even measure or test, plus or minus the diameter of a hydrogen or helium atom. Depending on the energy state, it'll be a helium or hydrogen atom, is the smallest atom you can do. Not enough difference to make a difference. But if we're okay with using the largest atom, which it's not fracnium, it's cesium. I will die on this hill. It's an argument. Go look on Reddit. You'll find it. Pi to 37 digits works just fine. And I write it out in the description of this video. And it ends in the 418. So even that's not needed. We can just chop it off and we'd be down to subcellular level accuracy over the diameter of the known universe if it was a circle or a sphere, which it isn't. We can make these work simply because math is pornographically precision-based within enough digits that you could get it as a tattoo around your arm or up and down your leg or something like that. I don't have that tattooed on me, nor do I have any of the other geek glyphs I always wanted to get tattooed. For medical reasons, I found out it's a bad idea for me to get tattoos because I have a tendency of getting infections that can be not borderline, but fully lethal, so I don't get tattoos. But anyway, how much precision is enough? We surpassed the precision level we needed back at the beginning of the modern era, we call it, from 1700s and 1400s. So why do we do the, well, it's an exercise in seeing how fast a computer works, because doing the math using calculus, or just simple division, which gives you a wrong number, but it's a very precise wrong number, we end up, if you're not aware of it, testing our computers for speed. And now we've hit another one. How fast is fast enough? Around 3 gigahertz is a sweet spot we've run into with the technology we have now, and we're all fairly comfortable with, and it does everything we need. So now how do we push people forward? Well, make an operating system shittier, like Windows 11, and throw AI everywhere to slow people down. Make your video games AAA treatment, meaning you do stupid shit like sticking AI in it to jack up the resolution and feed it deliberately crappier video or crappier data so you can stream your games. We're coming up with ways to devolve just to say we could do it, mostly so we can have fake innovation. Writing the shit out in multiplication tables in the 1800s is still the same peak level of math understanding that we need to navigate the detectable universe down to the diameter of the biggest and smallest atom by just removing or adding the letter 8, the number 8 at the end. That's fine. Or you can memorize, like I said, it's like a phone number, it's just a longish one. That's what she said. For doing it practical enough to get accurate enough to where you can do navigation within a solar system. And our solar system is pretty fucking average, by the way. If you use the bizarre scale of how far the Voyager 1 spacecraft has gone, that's actually well into the range of larger solar systems. And again, you're only off by under an inch. And if you're not aware of it, by doing the math, I did it really quick to double check it. At 125 billion miles, having it, that goes to basically 8 quadrillion inches. And when you convert that, yes, that's converting miles to inches, you end up with that being, if you do one more digit of precision, you end up with 0.8 inches of error, all the way down to 0.4 inches of error, depending on how you consider error, because that's a whole other video. So yeah, for Reddit mods out there, yeah, pi to that many digits that we're already using is just fucking fine for, you know, the molecular size error calculating the Earth's diameter, or the, you know, whatever, for the solar system or for the Earth. And again, down to less than 1 atom's diameter of error over a bizarrely large distance. But is this wrong? Or did I mix it up with the diameter of an atom if you measured the size of the Earth? Where am I must have made an error here. So, if any of you showed this to a Reddit mod and told them only to watch the 11-minute and 12-second mark, this is where you find out. I deliberately left an error in here that's just slightly wrong, and now you have to go look at all the links to find it. How to keep a Reddit idiot busy, or a YouTube expert, like me. Thanks for watching. Have a good day. Good luck with that. Troll, troll, troll.